Hello friends, welcome to Data Science Lovers. In this video, we will do some analysis of the sales data with the help of Python. Here we have the data set related to a restaurant company. We have the sales data of the restaurant company from different cities, or you can say different countries. And this data is available in Excel file format, and we are going to analyze and visualize this data. First of all, we will import the required libraries. As you know, import pandas as PD. Then we will import the matplotlib library to draw some charts and plots. Import matplotlib.pyplot as plt. Next we will also import the seaborn library. Import seaborn as SNS. We will run this and all the libraries are imported here now in this Jupyter notebook. Now we will import the dataset here, this Jupyter notebook, and we can name our data as data only, data equal to, and to import the dataset, the syntax is pd dot read underscore. Here, if the file is in CSV format, then we can write CSV, but we have the file in Excel format, so we have to write Excel here. And this is our dataset. This is a dataset that we will use. So we will copy its path from here and paste the path here. Okay. When I will run this, it will show a Unicode error. To remove this Unicode error, we can simply write a small r here and run this again. The command has been executed. To have a look at our dataset, we will write data here, run. So this is our data in this Jupyter notebook. Here you can see we have 263 rows and 10 columns. This is a sample data set only to show the analysis and visualization. Now if we want to check some information about this data set, then we can use the info function on this data.info function. Run this and it will show all the basic information about our data set. It is showing that it is a data frame and the range, or you can say rows or records, are 263 and the index is 0 to 262, and there are total 10 columns which are named here, and here it is showing the data type of each column. The first column is float and other columns are object, and you can see here float column 1, object column 9. Okay, now our first task here is dropping the unwanted column. As you can see here, this first column is of no use, so we will drop this column using the drop function, and the syntax will be our data frame name dot drop function, and here we will write columns because we have to remove the column, equal to, and here we have to pass the column name. We will simply copy this column name and in the quotes we will pass this. Okay, and when we will run this, you can see the first column is removed here in this result, but actually it is not removed. So to remove this permanently, we have to pass a command in place equal to true. In place equal to true is used to make the changes permanently in our data frame. Okay, when we will run this and have a look at our data frame now, you can see that the column has been removed here. The next thing here we have to do is changing the column names. In this data frame, you can see the column names are named as unnamed 1, 2, 3, 4 and so on. This is because in our actual Excel sheet, the first row is blank. So from here it is showing unnamed 1, unnamed 2, and in our second row the actually column names are present, and here our column names are present in our first row here. Okay, so we can also do this by simply deleting this row and import the data set again. Okay, but we will solve this problem using the Python. So how we will do this? We will use the log function for this. Our data frame name and log function. In the logs function, if I pass 0, 0 here is representing the index of the row. At 0 index, the column names are present. When we will run this, it will show all the values that are present at row with 0 index, order ID, date, product, city, and that's all. Okay, now we have to move this row to the column names. If we check the column names by using the columns command and run this, it is showing that the present column names are unnamed 1 and until unnamed 9. To change the column name here, we have this simple command. We will consider our columns like this, okay, and equal to what we want here. We want the values that are present at our row with index number 0. So we will simply pass equal to data dot log and 0. We will run this. The command has been executed. Now if we have a look at our data frame, then you can see that the column names are changed now. Now in the next step, we will simply remove this first row. To drop any row, we have to use the drop function. Our data frame name dot drop, and inside this function we have to pass the index of the row, or you can say record, that we have to remove. Here we have to remove the index 0, so I will pass 0 here, and when we will run this, you can see that the first record have been removed. Okay, but in actually, if we have a look at our data frame again, then this is still present here. So as I told you that to make the changes permanently in a data frame, we have to use the command in place equal to true. When we will run this again and have a look at our data frame, then you can see that the changes has been done permanently and our first row have been removed here. Now we will use the info function again on this data frame to check some differences. Here again, it is showing that the index range is now from 1 to 262. Earlier it was 0 to 262. Okay. Earlier there were 10 columns, as you can see above. Here if we see, there were 10 columns, but now as one column is removed, so there are 9 columns. Okay, and these are the column names, and there is no null value in any column as it is shown here, and the data type of all the columns is object. Next is we have to consider the manager column. Here there is some error, or you can say we have to correct the entries present in this manager column. This is our data frame. When we show the values of this column, then you can see there is a space between the first name and second name. Also there is a space in the starting as well, and in the end as well there are spaces, so we have to remove these spaces. So if we use the unique function to show how many unique values are present in this column, then you can say these are unique values present here, and how many values are there, we will use an unique. There are total 14 values here. Okay, now to remove these extra spaces, we have some functions that we will use on this column. Data manager, you can consider any column by writing like this, or you can write like this. Okay, so here we have to use str.strip function, strip, and this one. Okay, When we will run this, it will remove all the extra spaces from these names. Okay, as you can see, there is space, but now there is no space. We will make changes to our column. So I will pass here my column name again, manager, equal to this. Now if we have a look at our data frame, I will show top 20 records to have an extra look. So there is no such error of spaces now in this manager column. Also, if we check the number of unique values and want to see the unique values, dot unique, here are how many values, dot an unique function to show the count of unique values in any column. Here are total 5 values now. Earlier there were 14 values. Okay, like this. The Tom, Jackson, it is showing like this also, and Tom Jackson, it is showing like this also. Okay, similarly Jao Silva, it is showing like this, and same like this. Okay, so this is the syntax or command to make the changes in a string column, or you can say object type column. Now we will move one step ahead, which is cleaning of our dataset. First of all, we will remove the all duplicate records from our dataset. Let's have a look at the dataset. This is our dataset. If we use the describe function on this dataset, in order ID, there are total 262 counts, but the unique values are 254. Means there are some duplicate records present here. Okay, and in the product there are 262 entries, and there are 5 unique products. From here you can also check these types of information as well. And if we see the purchase type column, there are 3 types of purchase types. Okay, and the top means the most used purchase type is online, which is 107 times out of 262. Similarly, if we consider the payment method column, the credit card is the most commonly used payment method, which is 128 times out of 262. Okay. Now to show the duplicate records from a data frame, we have a function called duplicated. How to use this function? First of all, we have to write our data frame name, and then we have to write duplicated function. Okay. When we will run this, it will show the result like this in the form of true and false. False means the record is not duplicate, and where there is true means the record is duplicate. But we have to show the result in other format, like in the format of a data frame. So we will write our data frame name again here, and we will pass this command in the square brackets. And when we will run this, it will show only the duplicate records now. As you can see, there are total 5 duplicate records. Now we have to drop these 5 duplicate records from this dataset, and to delete the duplicate rows, we have a simple function which is called as drop duplicates. So how we will use this function? First of all, we have to use our data frame name data dot, and here we have to use drop duplicates. And when we will run this, it will show the results after removing all the duplicate values. But to make the changes permanently, we have to use in place equal to true. When we will run this again, the command has been executed, and if we check for duplicates now again by copying this, then you can see it is showing 0 records, means now there is no duplicate record in our dataset. If we use the describe function on our data frame again, data dot describe, then here we can see that the total count of order ID is 257, but it is showing unique values are 254, means still there are 3 duplicate order IDs. So what does it mean here? Let's check from our Excel sheet. This is our Excel sheet where our original data is present. In order ID, if we check the duplicate like this and filter only the duplicate records, here it is showing these are the duplicate order IDs. Okay, now earlier there were 5 totally duplicate records. I will highlight these records for you. Order ID 457, 468, 457 and 468. Next is 537, 538 and 539. Okay, here 537, this one, 538, this one and 539. Okay, these duplicate records we have removed already from our data frame, from here. Okay, now still we have 3 order IDs that are duplicate. Here if we see 10 483 and 10 483. Okay, we will highlight these records like this. Here when we check that the date and product and quantity and other columns values are same, but there is a difference in the price column values. Here the price is 33.22, but here the price is 2.95. So that's why there are different order IDs, means there are some error in this data set. Similarly, if we check 10 484 and 1084 here, and we will highlight this some other color, orange. Here also the product is same, but there is a difference in price, 21.44 and 4.99. Similarly, in this column, in this row 485 and 485, the products and dates are same, but also there is difference in price, means this is a error in price column for these 3 order IDs. Okay, we have to correct this. Now as we used this duplicated function on our whole data frame, we can use this same function on a single column as well. So we have to consider our order ID column here, order and ID dot duplicated. When we will run this, it will show the result in boolean format, true and false. To get the result in a data frame name, we have to put these commands in a square bracket, and before this we have to pass our data frame name. Then it will show the result in desired format. When we will run this, it will show the duplicate order IDs as we see here, 483, 484, 485. Okay, here it is showing 483, 484, 485. From this sheet we can check the actual price of the products, where if we check the first is beverage, then you can see 2.95 is the actual price, but this is the incorrect price, so we have to correct this. And next we check the price of burgers, then 12.99 may be the actual price, and we have to remove this 27.99. And similarly for fries, the price is correct for all entries. And for next product, sides and others, the price is 4.99, but this is the incorrect price. So we have to consider these rows where the price is incorrect. Okay, so we have to deal with these 3 rows where the entered price is too high. Let's check the index of these records using the filtering method, and then we will remove these records. Okay, so our data frame name, we have to consider the order ID column. Here first we have to check the index with the order ID 10483. Okay, when we will run this, it will show the result in boolean format and data here, and run this. So these are two records where we have order ID 483. Okay, so as you can see, at index number 32 the price is 33.22, which is incorrect, so we can remove this row. Okay, similarly we will check for other two order IDs as well, 484 and 33. Index number we have to remove, and similarly we will check with last order ID 485, and here the index is 34 where the price is incorrect, so we have to remove these three rows which have index number 32, 33 and 34. To check how we can remove these rows with their index number, we can check our notes here. Here if we see how to remove the records or columns, we can, here if we see removing rows by the index name, or you can say index number, we have to use our data frame name and the drop function, and inside the drop function we have to write the index name. Okay, so we will use this. Now our data frame name dot drop function, and inside the drop function we have to write the index value. First we have to remove this 32. When we will run this, it will remove the index 32. Here also, to make the changes permanently, we have to use in place equal to true. When we will run this, the command has been executed. If we use the same command again to check the duplicacy, I will copy this and paste here and run this. You can see that now that index number 32 with their records have been deleted now. Okay, similarly we can remove other two indexes 33 and 34. Again we will use the this drop function, data dot drop. This time we have to remove two indexes, so we can use the index number in the form of a list by using the square brackets and 33 comma 34. Okay, again in place equal to true. We will run this. There is a syntax error, sorry, we have to write the comma here. Run this and the command has been executed. Now if we check these commands or to check the duplicacy again, then it will show the required output like 67 only, and 33 index number have been removed. Similarly with this command, and here also the index number 34 is removed and it is showing only 68. If we check the duplicacy in order ID column now by using this same command, and we will run this, then it is showing 0 records, means now in the order ID column as well there is no duplicate records. I have put the commands for all the commands in this file. You can download this file from the link given in the description of this video. Here as you can see what does this duplicate function do to check the duplicate records in a column, and like this all. You can also check our notes, these notes, pandas, numpy and others, and the link is also given in the description of this video. Next part is converting the data type of the columns. If we check the data type of each column of this data frame using the info function, then we see that the product data type is object, and also the data type of price and quantity column is in object format, but it should be in numeric format, or you can say in integer format. So we will convert these data types. First we will convert the data type of the quantity column, and we will consider the quantity column dot quantity using the hash type function on this column, and we will convert this data type into float format. So we will write float here. When we will run this, it will show the result like this. And to make the changes permanently, we will again write our column name data.quantity equal to and this one. So it will make the changes in our quantity column, and when we will use this info function again and check this, then you can see that the data type of quantity column is float now. Now we will round off the values of this column using the round function. So again we will use the same syntax like this, but this time we will use the round function on this column, round, and run this. The command has been executed, and when we check the value of this column now, it will show the result like this. And to remove this point or decimal and zero values as well, we will again convert this column into integer format, and this time in the s type function we will write the int and run this. The command has been executed, and if we have a look at our column now, the values are now in this format. You can think that why we haven't converted the data type into integer format directly. There is a reason. If you see here this value 745.76, if we convert the data type of this quantity column directly into integer, then it will show only 745 value. Okay, but now it is showing 746 after the rounding of the values. Okay, so this is the reason that we have converted this into float data type first, then the round off, and then at last in the integer format. We have to convert the data type of other columns as well, which is date, and we have to convert the price column data type also. Okay, and we have to convert the data type of order ID also. So let's do this with order ID first. Data order ID column dot as type, and the order ID column will be converted into integer data type. Okay, next we have to convert the data type of price column. Again data and price column dot as type, and as you can see there are the decimal values in this price column, so we have to convert this in float data type like this. And here we will pass the column name to make the changes in that particular column. Here also data price equal to like this. We will run this, and if we check the data type now, then the data type has been converted, order ID into int and price into float. We have to also change the data type of this date column. It is in object format. We have to convert this data type into date time format using the date time function. If we check from notes, the date time, okay, so pd dot to date time, it will convert the data type of date time column into date time ns data type. Pd dot to underscore date time, and here we have to write our column name, which is date. When we will run this, the data type has been converted. We will save this in our original column data dot date equal to like this. When we check the data type of this column now, data dot date using dtype function, and run this, it is showing the data type is converted now. And we can also check from info function. Here also the data type is date time now. At this point we can see that our data is cleaned and the data type are in proper format. Now we can move to the analysis part of this video and final look at our data. This is our data here, okay, with 254 rows. And as I told you, this is a sample data set, but in real you will get a data set with thousands and millions of rows. Moving toward analysis and visualizing the data, the first question is, what is the most preferred payment method here? Let's have a look at the data again. Using the head function, it will show top 5 records, and we have to consider this column payment method. Let's first check how many types of payment methods are there. We will use the unique function for this, and we will consider the payment method column. You can copy the directly column name to avoid any mistake in the column name here. Okay, dot unique function on this. Run this. It is showing the payment methods that are available. The first one is gift card, second is credit card, and third one is cash. Okay, you can also check the how many counts, or you can say how many unique values are there present in any column using the unique function. So when we run this, it is showing 3, means there are 3 types of payment method. As there are only 3 payments method, you can easily see here, but suppose in any column there are multiple values, multiple unique values, suppose 20, 30, then you cannot count each value. So in that case you can use the unique function. Now to get the count of each payment method, we can simply use the function which is called value counts. Payment method, we have to consider this column again, and we will use value count function. This is very important function. You can consider on any column. Run, and here you can see credit card is the most preferred method out of the 3 methods, where the transaction is 120 times out of total 254 times. Okay, and second one is cash, which is 76 times, and gift card is 58 times. We can also check the percentage of these 3 values, and to check the percentage in the value count function, we have to write normalize equal to true. Okay, when we will run this, it will show the result like this, and we can multiply this by 100 to get the percentage. Here you can see the credit card, the percentage of overall transaction is 47%, cash transaction is 29.9%, while the gift card transaction is 22.8%. We can also draw a bar graph for this, and what we will do, we will consider this column and we will use the value count function. After this, we will use the plot function. Inside the plot function, what kind of chart or graph we want, we have to put here kind equal to bar. When we will run this, it will show the result like this. Okay, credit card, the most percentage, then cash, then gift card. So this is the output here. And if you see this one comment, or you can say line here, to remove this line from any chart or graph, you can simply put a semicolon here and run the command again, then the line will be disappear. Okay, the next question is, which one is the most selling product? This question has 2 parts. First we have to tell the most selling product by quantity and then by revenue. Okay, then our data frame. First we will consider the by quantity. As it is clear, to get the answer of this question, we have to work with 2 columns. First one is product and second one is quantity. And here we will use the group by function on our product column. The syntax to use the group by function is our data frame name, which is data here dot group by function, and inside this function we have to write the column name on which we have to use the group by. We have to first use the group by on product column. When we will run this, it will create the group of all unique values that are present in this product column. I will explain this how this group by works through the Excel sheet. Let's first get the answer here. After creating the group, we have to consider our second column, which is quantity. And so our second column will be put in the square brackets, and here quantity. And for the quantity column, we want the sum of all the quantities of the unique values. When we will run this, it will show the output like this. Here it is clear that the beverages is the most selling product by quantity, and the quantity is 34988, while the sides and others is the least selling product with the quantity of 9800. Now how this group by works. Suppose we have this Excel sheet and we will use the filter on the product column. When I will select only one, you can say value burgers. Okay, it will show the result of burgers only. And while we were using the group by, it were creating the group of all the burgers. Okay, from here it will consider only burgers quantity here. And second column we were considering the quantity column, and here quantity column we were using the sum function. So it will sum all the values of this column where the burger is present. Okay, here if you see, the total sum is coming 29022, and here also the sum of burgers is coming 29018. There is a little difference here because of the round off that we have done above. So this is the basic concept of group by, how group by works. Suppose we take another value like fries. Okay, in fries it will consider only the fries value from this product column, and it will do the sum of all quantities against it. Okay, here if you see, the value is coming, total sum is coming 32034, and here also it is 32023. Okay, so that's how group by works. Again I am telling you, the little difference in this sum is due to the round off of the values that we have done. Here you can see the quantity in this unclean data is 573.0 and this one, and after rounding off we have made it 573. Okay, here there are only 5 values, so you can easily check out the result or the sum of each value. But these values are not in ascending or descending order. We can sort these values as well. I will copy this and paste, and we will use the sort values function here. When we will run this, it will show the result in ascending order. We can also use the descending order, and here we have to write ascending equal to false. Then it will show the result in descending order. Okay. Now we will draw a bar graph for this output, and to do this we have to save this command in a variable, and the variable name we are considering here is most quantity. You can consider any value or any variable name. You can write x, y, z as well, and this one most quantity. Okay, if we check the type of this variable most quantity, and it will show that it is a series. Here we have to convert this output of series format into the data frame format, and for this we will use a function which is called reset index. When we will run this, it will show the output like this in a data frame format where we have columns and rows. Again we will save the output in this variable. Okay, run this, and it is the output. Now if we run this command again, then you will see it is a data frame now. To see what this reset index function do, we can check the nodes here, reset index, and it is written here to convert the index of a series into a column to form a data frame. I will copy this and paste here for your understanding. Now we will draw a bar graph for this output using the matplotlib library, and the syntax will be plt.bar. First we have to pass what we want on x-axis, then we have to pass what we want on y-axis. On x-axis we want the product from this data frame, so we will consider this data frame most quantity, and we will consider the product column. This is our x-axis, and on y-axis we want the quantity. So we will write like this. When I will run this, it will show the output like this. We have to simplify this bar graph. Let's first set the size of this bar graph using the fig size function, and the syntax will be plt.figure, and inside this function we will pass fig size, and here we will pass the length and height. The length should be 9 and height we can consider as 4. Running this, it will show the output like this. Here we can color these bars of our choice. So here we have to pass the 5 colors like this. Color equal to red, black, green, yellow, can. And run this, it will color the bars. We can also uh, set the width of this bars using the width argument, and we can set as 0.4, and running this, the width is set now. And as I told you, to remove this unwanted comment or line, you can simply pass a semicolon at the end of this command and run this. This is the output. We can also set the title or x label or y label for this graph using the title function. Here we have set the title as most selling product, the x label as product, and y label as quantity. Okay, so here is the title, the quantity, and product. Now we will see the most selling product by revenue. Have a look at our data frame add function. To get the output with respect to revenue, first we have to create a new column in which the revenue will be shown. And to create a column, as you know, our data frame name and our column name, new column name, revenue. Inside this column, what we want the multiplication of the price and the quantity. So we will consider the price column, price multiplied by quantity, and run this. The column has been created, and have a look at our data frame. Now as the column is created, now we will use the group by function again, and this time we will use product column and the revenue column. So the syntax will be the data frame name data dot group by function, and inside this function we have to pass our first column product on which we want to use the group by, and then we have to pass our second column, we have to consider the revenue column, and dot sum because we want the sum. Here also I am using the sort values, and we want the values sorted in ascending order, so I will pass ascending equal to false. When we will run this, it will show the output. The burger is the most selling product by revenue, while sides and others is the least selling product by revenue. If you notice here, the syntax of this answer and the syntax of this answer is almost same. The change is only in the second column that we consider. Here we consider the quantity column, while in this case we consider the revenue column. So you have to learn this, how we can use the group by function on two different columns. Now we will draw a bar graph for this output as well. And to draw the bar graph, we have to save this output in a variable, and here we will choose the most revenue as our variable name and paste this. Okay, run this. As it is a series as of now, we have to convert this in the data frame format using the reset index function that we used above. Most revenue dot reset index function. This is in data frame format, and we will make changes to the variable like this. Okay, there is a spelling mistake. We have to write here revenue. Running this command and the data frame has been created. Now we will draw a bar graph using the matplotlib library. plt.bar. On x-axis we need the product column, and on y-axis we need the revenue, and running this it will show a simple bar graph like this. And now we have to modify this bar graph as per our requirement. We have set the size of this figure as 9:4. Also there is color for this bar. Now the 5 colors are given and the width is set as 0.3. After running this it will look like this. We can also mention the title and X level, Y level as well. The title is given as most selling product by revenue. On X level, on X axis we have product and on Y axis we have revenue. Running this, and this is the title, this is Y axis and this is X axis. Moving to the next question, which city had maximum revenue, or which manager earned the maximum revenue? These two questions are same. Let's see how and what is the result. This is our data frame. Here we have to consider the city column first. This one. Let's see how many unique cities are there. So to check the units cities, we have to use our city column dot unique function. There are 5 unique cities, and you can check the count also here. Okay, 5 unique cities are there. Now we will use the group by function on this city column, and as we have to check the revenue, so the second column that we will consider here is revenue. First of all, let's use the group by function, and the syntax will be data frame name dot group by function. Inside this function we have to pass our first primary you can say column, which is city. This second column will be passed in square bracket. Here we have second column is revenue, and we have to check the sum, and when we will run this it will show the output like this. We have to sort this, sort values, and we will sort in descending order. Ascending equal to false. Okay, so as it is clear, Lisbon has the maximum revenue, then London, then Madrid, Pernil, and then Paris. Okay, now let's check the second part, or you can say second option of this question, which manager earned the maximum revenue. Here we have to consider the manager column and also the revenue column. So let's first check how many values are there in manager column. I will use an unique function. The 5 managers are there. We can also check the name of the managers using the unique function. So these are the 5 managers: Tom, Pablo, Jao, Walter, Remy. To get the revenue manager wise, we will group all the managers from this column, and the syntax will be our data frame name dot group by. The first column we have to group is manager, and the second column we have to consider is revenue in this case as well. Dot sum, because we want the sum of revenues. So this is the output. We will sort this also. Sort values ascending equal to false, and when we will run this, it will sort the values like this. Jao Silva had the maximum revenue, then Tom and others. Now, if you notice the one thing, that the revenue value here 241635 and 241635 means the revenue values of all 5 cities and revenue values of all 5 managers is same. And from this we can notice that Lisbon city manager is Jao Silva, and while Tom is manager of London and Remy Monet is manager of Paris. Okay, so that's why I said you that these two options are same. Moving to the next question. The next question is we have to show the date wise revenue using the some chart or graph. This is our data. Here we have to consider this date column. Before using any date column in any data frame, we have to check the data type of that column. So simply we can check like this: data, the column name, and dot the type function. It is in date time format. It is called the date time format. Okay. Also, you can use the info function to get more clarity. It is in date time. Okay. Now we will draw the line chart for this. Data frame name dot plot, and first column we will consider is date. The second column we will consider is revenue. When we will run this, it will show the output like this. We can modify this output. I have set the color of the lines as red. The line width is set to 2 and the size of figure is also extended to 9 by 4. When we will run this, it will look like this. Here on a particular date, the revenue is too high. This may be an outlier, or there may be some occasion or festival on this particular day where the revenue is too much. We can also set the title, the X level, Y level for these charts. The title of this chart is set as date wise revenue. On X axis we have date, on Y axis we have revenue, and plt.show is used to show the chart. So this is the outcome of this chart. Moving to the next question, it is asking what is the average revenue. This is our data frame. We have to consider the revenue column, data and revenue, and to get the average we will use the simply mean function. So this is the average revenue here for this data 3028. Next question is what is the average revenue of November and December month. Data.head function. Here we have to create a new column of month using this date column. So the syntax will be is given here. We have to use our data frame, then our date time column, then dt.month. Let's see how to use our data frame name, our date column, this one, and then dt.month. When we will run this, it will show the months. We will save this output in a new column, and the column name will be month equal to this one. Now if we see our data frame, then a new column has been added at the last that will show only the month. This one is 11 means November and 12 December. Okay, so now we can easily check the sales of each month. Now there are many ways to check the output or the revenue. First, from this database we will filter out only the records having the month of November like this data, and we will consider the month column equal to 11. Okay, and data frame name, the square bracket and square bracket close. it will show all the records where the month 11 is present. We will save this in a variable called m11 equal to this one, m11. Now we can easily check out the average revenue here. From this data frame m11, we will consider the revenue column and we will check the mean like this. So the mean value for November month is 2938. Similarly, we can check the revenue for December. Here we will filter out the records with the month 12 or December. So data.month equal to 12. It will show result in true false. Our data frame name, the square bracket start and square bracket close. Okay, so these are the records where the December is present. We will save this in a new variable called m12 equal to this m12. Now from this m12 data frame, we have to consider the revenue column and dot mean. So this is the mean revenue of December column. Moving to the next question, what is the standard deviation of revenue and quantity? The standard deviation of, first we check for quantity dot std function, simply we will use this, is 214.97, and similarly for revenue dot std, the standard deviation is 2419.9. One more similar question, what is the variance of revenue and what is the variance of quantity? We can copy this column name quantity and here we can use the variance dot var function. The variance is 46216 for quantity, and similarly we can check the variance for revenue and the variance var function. We run this and the variation for revenue is 5856073. So that's how you can check the standard deviation, the average and the variance of any numerical column. Next is revenue increasing or decreasing over the time? The answer of this question we can get from here also. In November month, the mean revenue was 2938, but in December month, the revenue was increased and it was 3101. The mean revenue was increased. So we can say that by the month, the revenue is increasing, and we can also check the sum of the revenues for each month. Data. We can consider the above two data frames of November and December month here also to check the sum now. So we can check the sum M11 and here revenue dot sum. The revenue of November month was 332015. Similarly, we can check the revenue for December month. Okay, M12 containing all the records only of December month. M12 dot revenue column dot sum. So you can see that the revenue is 437284 in December month. So there is a too much increase in the revenue for the next month. The last question is, what was the average quantity sold and average revenue for each product? Here in this question we have to consider three columns: the product, the quantity and the revenue. So first of all we will use the group by to make the group of all unique products, and data dot group by. First column we have to consider the product. Now it is asking for the average quantity sold. So second column we have to consider is quantity, and it is asking for the average revenue, and the third column we have to consider is revenue. Okay, Now we have to check the average or mean of these two columns. So to check the or you can say to apply any function on two different columns at the same time, we have to use the aggregate function, and the syntax will be dot ag, the round brackets. Here we have to use the dictionary format, our first column name, the quantity, and what we want the mean. So we will write the mean. Also on the revenue column we have to write the second column name, revenue. On the revenue column as well we need the mean. When we will run this, it will show the output like this. From this output we can clearly understand these are the products and these values are the mean of the quantity for each product, and these values are the mean of revenue for each product. So for beverages the mean quantity sold was 699, okay, and the mean revenue was 2064. For burgers the mean quantity is 558 and the mean revenue is 7248, and so on. So that's how we can use the aggregate function on two different columns while we are using the group by function. Okay, that's all friends for this project video. You can check our notes also, the core Python notes, NumPy, Pandas, Matplotlib, also the SQL notes. The link of these notes is available in this video descriptions. Also, the link to download this solved Jupyter notebook file is given in the description of this video. Thanks friends, kindly like this video and subscribe to our channel for more such videos.